Okay, so I'm at AWS reInvent, so there's a fair bit of noise. Sorry about that, but if I don't get this done today, I will not get it done. Falling behind is not good for me. So yeah, admin of code, same as usual. Um, 25 puzzles spread throughout the month of December, and it started last night, midnight on December 1st, as always. So let's just get right into it. So I'll read through the problem description for day one, and then we can take a look at the solution that I came up with. Um, yeah, okay, so day one, calorie counting. Santa's reindeer typically eat regular reindeer food, but they need a lot of magical energy to deliver presents on Christmas. For that, their favorite snack is a special type of star fruit that only grows deep in the jungle. The elves have brought their own annual expedition to the grove where the fruit grows. To supply enough magical energy, the expedition needs to retrieve a minimum of 50 stars by December 25th. Although the elves assure you that the grove has plenty of fruit, you decide to grab any fruit you see along the way just in case. Collect stars by solving puzzles. Two puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Okay, so that's an introduction to like the overall puzzle. You have to collect all these different stars, and you get one for each one you solve. So if you solve all 50 of them, all 50 puzzles, uh, you're gonna get the 50 stars, and you're gonna help Santa. It's gonna be great. Okay, so today's specific problem is as follows. So let me just find the right window here. Sorry. Okay, the jungle must be too overgrown and difficult to navigate in vehicles or access from the air. The elves' expedition traditionally goes on foot. As your boats approach land, the elves begin taking inventory of their supplies. One important consideration is food, in particular, the number of calories each elf is carrying. This is your puzzle input. The elves take turns writing down the number of calories contained by the various meals, snacks, rations, etc. That they've brought with them, one item per line. Each elf separates their own inventory from the previous elf's inventory, if any, by a blank line. For example, suppose the elves finish writing their items' calories and end up with the following list. And then we see 1,000, 2,000, 3,000, 4, 5, 6, 7, and so on and so on. And the thing, now let's let's read it to the end and then talk about it. Okay, so this list represents the calories of the food carried by 5 elves. The first elf is carrying food with 1,000, 2,000, and 3,000 calories, a total of 6,000 calories. The second elf is carrying one food item with 4,000 calories, and the third elf is carrying food with 5,000 and 6,000 calories, a total of 11,000 calories. The fourth elf is carrying food with 7, 8, and 9,000 calories, a total of 24,000 calories. The fifth elf is carrying one food item with 10,000 calories. In case the elves get hungry and need extra snacks, they need to know which elf to ask. They'd like to know how many calories are being carried by the elf carrying the most calories. In the example above, this is 24,000, which is carried by the fourth elf. Find the elf carrying the most calories. How many calories is that elf carrying? So in this case, it's the 24, so 24,000. Yeah. So what it took me a second to realize here is that even though they are in order, they don't have to be. It kind of looked like they had to keep running total rather than list the individual things that they carry. So um, with that in mind, this is what I came up with. Oh, I need to change this one, I think. Yeah, there we go. Cool. No, there we go. All right, so I did it in Python and Go. I think the Python one is probably easier to look at. So the first thing I did is I took the data and the sample data, and I put it into a sample of text. This way we can create a test case, and we can. This one was relatively straightforward, but if it's a much more complicated problem, it's really handy to have a unit test that you can use to validate that what you're doing is right before you start having to um, check your answer. Because whenever you submit an answer and it's wrong, you have to wait another minute. So especially if you're trying to be competitive about this and trying to do this in as little time as possible, this is something you want to focus on. I just think it's handy because it's a very small problem, and it almost always exercises all the different problems or like edge cases that you might come across when having to solve the problem for real. So that's the first thing I did. So yeah, this is the test case for part A. So using the sample input, it's supposed to give us 24,000, and then we have the code over here. Um, yeah, ignore this for now. Let's just get rid of it. So we don't spend time looking at it. Okay. So first we have the get sums, which opens the file. I imagine the structure is gonna uh, replicate every single day because it's always there's the input file, and we load it in. We try to put it into a format that's easy to work with, and then we kind of solve the problem. So there's usually these two elements to it: loading it and getting it into a format that's easy to work with, and then actually addressing the problem as it's been stated. So this is the loading part where we get the sums, create an array and called sums, and we create another variable called sum, which starts out with 0. And then for each line, we strip any white space there might be, and if we after stripping it, we get the empty string. That means that we're looking at an empty line, and then we take whatever we've accumulated so far for this one elf and add it to the sums array up here, reset the sum, and continue. Continue goes to the next iteration. So goes back to the top of the for loop. If it's not an empty line, then we turn the string that we had from the file, turn it into an integer, add it to the sum, and we go back to start. And in case we don't end with an empty line, once we're done with the last line of the file, we make sure that we add any the sum of the final elf's stuff, and then we return that. And then part A was supposed to find how many calories were carried by the elf carried the most. And Python makes it very easy. You have an array with a bunch of values in it, and then you can just call max on it, and you get your value. And our little test runner thing over here. Yeah, that got a little complicated as I was cleaning up, I guess. Okay. We can just go like this. We can do, because it's not 2008 anymore. But this is going right there. Yeah, it passed. And as soon as it passed, that meant that I knew that I could just run Python 3. No, over there. Python 4. And I got my answer right there. And I took that and I entered it in. Sorry, still getting the hang of this. Yeah. And I entered my answer. Well, there was an input box here. It's not up there anymore because I finished it, but it was there. Put it in, and you get it's like, congratulations, you solved it. Here's a gold star. Everything's good. Cool. So the next part of the puzzle is part 2. I always call it part B. Maybe I should stop doing that. Anyway, part 2. By the time you calculate the answer to the elves' question, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. So to avoid this unacceptable situation, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. And that way, even if one of the elves runs out of snacks, they still have 2 backups. In the example above, the top 3 elves are the 4th elf with 24,000 calories, the 3rd elf with 11,000, and the 5th elf with 10,000. And the sum of those is 45,000. So find the top 3 elves carrying the most calories. How many calories are those elves carrying in total? So, very similar problem. Let's oh, sorry, switch to Windows. Here we go. Okay. Right. So the data loading is still the same. We come up with the array of their totals. And I'm going to resurrect my part B here. Very simple. Called getSum, so I get the same data as before. Any functional programmers out there, or well, a lot of people are gonna be very offended by me reusing this variable, but here we are. So Python sorted sorts the elements of the array that it's given and returns it in sorted order. And then I simply return the sum of this expression here, which gives me the last 3 elements of the sums array, and boom, that's it. And that made this test case pass, and I can run the code, and I got my answer, and yeah, that's pretty much it. I have a Go version, yeah, here, using the exact same approach. I figure that at some point, as these exercises get more complicated or something, that the solution in Go and Python is going to look different because they have different stuff that just makes it easier to express it in different ways sometimes. But for now, if I'm using the same approach, I try to keep it very, very similar, so that you can almost kind of look at, let's see, you know, okay, main. So you can see part A, okay, get sums, and Go doesn't have a max function out of the box, so we just came up with the get highest, which does the same thing. Part B, pretty much the same thing. The Go version of, it's not the same, but what the built-in sorting thing acts in place, so it doesn't return new ordered sums array, but just sorts it in place. And then again, there's also no easy sum function on Go, so I just, well, in this case, it was pretty easy to just type them out, like 3 of them. If there were many, I would not have done it like this, obviously. Yeah. Loading the data is pretty much the same. You open the file, typical Golang error handling, create the empty array and the sum, and then to iterate through the file one line at a time, we need the scanner. So that's basically what this does. And then it goes through all the same steps with trimming, or stripping in Python. If it's empty, then we append, and so on and so on. Yeah, and that's pretty much it. Not a lot of surprises in this one, except I've signed up for GitHub Copilot, and it was actually this whole function, I think. Yeah, Copilot wrote that. I was here. I'm like, oh, I need something that can get me the highest value. So I just pretended like get highest already existed, typed that out. Then I went down here and I started typing func get highest, and yeah, magic just started happening. You can kind of see here. So uh, let's just try some. Let's get second highest. Okay. Okay. So it wants to sort, and then yeah. See. Um, yeah. I'm not sure why this one took a different approach. It doesn't really matter. Um, Either way is fine, really. Especially with the data sizes that we're dealing with. If this was a ginormous array, if you only needed the highest one, you wouldn't necessarily bother sorting them first. You just need the highest one, and you can do that just going through it once. You don't have to, yeah, do the whole sorting thing. Um, but yeah, this is pretty much it. I think what seems to be different from what most other people I see solving these is that I start out with those unit tests because it actually helps. In my day-to-day work, I almost never do. Um, it's just it's apparently just not how my brain works. But in this situation where it's very well specified, this is my inputs and this is what I want from my output. It's really easy to just go ahead and do this, and it's very very helpful. Um, so I highly recommend that. Yeah, if there's anything that's unclear, leave a comment or something, I guess. And yeah, if you want to like or subscribe, that sounds cool too. All right, that's it for today. I'll probably still be here with all the noise tomorrow, but the next day should be more tolerable in terms of like the soundscape here. Uh, yeah, I think that's all I have to say for day one of Advent of Code 2022, and I think it's gonna be amazing. So play along, and I will see you tomorrow.